Okay, so we're going to have a look at another question from the topic of electromagnetism. We're told an alpha particle enters a vertical, uniform magnetic field at an angle of 30 degrees to the field. The field points up and has strength 30 milliteslas. The initial velocity of the particle is 150 meters per second. We need to draw a diagram, calculate the initial acceleration, and then find the alpha particle speed after 5 seconds. Now we're going to do this under a very specific condition. This is not a condition you will always see, but the condition we're going to use is to assume constant initial acceleration. And again, that's not always going to be done. You can answer this question half a dozen different ways. This is the condition we're going to use for part C. So first we need to draw a diagram. We have a vertical uniform magnetic field and it points up. Okay, so we have a magnetic field and it goes up like this. Now we're told the particle enters at an angle 30 degrees to the field. So it's going to be there's a few different ways to interpret what this means, but the way we'll do it is something like the particle's here and it's entering this way so that this angle is 30. It has an initial velocity of 150 meters per second. The field strength is 30 milliteslas. And this is an alpha particle. So this is an alpha particle. So this is a crude diagram. This is good enough for our purposes here. Now we are told to calculate the initial acceleration. So we're going to do this in quite a simple way. We're going to say that the acceleration is in the direction of the force, and we have a formula for acceleration. Acceleration is the charge of the particle times the velocity times the field strength times sine of theta divided by the mass. Now when we set up this formula, we said that theta was an angle between the velocity vector and the magnetic field vector. And so that means in this case, 30 is theta. So this gives us immediately, we have an acceleration is charge times velocity times field times sine of 30 divided by mass. So now we just need to plug everything in and then solve. So we were told that this is an alpha particle. We've encountered alpha particles a few times in this course so far. You may have memorized the charges and the masses, you might not have, but the charge of an alpha particle is roughly 3.2 times 10 to the minus 19 coulombs. You have to multiply this by the initial velocity, which we're told is 150 meters per second. We have to multiply this by the field strength, which is 30 milliteslas. So that is 3 times 10 to the 1 milliteslas. We need to divide this by 1,000. So 1, 2, 3. This will give us 0.03 teslas. 0.03 teslas times sine of 30, all divided by the mass. And the mass of an alpha particle is about 6.6 times 10 to the minus 27 kilograms. So now we can plug all of this in to our calculator. We're going to get 3.2 times 10 to the power of minus 19 times 150 times 0.03 times sine of 30. This is all being divided by 6.6 times 10 to the minus 27. My calculator tells me that therefore the acceleration is about 1.0909 ... times 10 to the 8 meters per second. So this is our answer to part B. This is the initial acceleration of the particle upon entering the field.